Hello there, Charger family. This is Mrs. Boyd at Mrs. Boyd's Math Room. Thanks for joining me today, where we're going to talk about slopes of lines. We've definitely talked about slope before, so just a little bit of a refresher course for us today. The slope formula is M always equals y2 minus y1 over x2 minus x1. And this is with us being given x1, y1, x2, y2. Okay, so now we're going to use that formula to solve for the slope between these 2 points. I'm going to label my points x1, y1, x2, y2, and plug them into the formula. M equals 9 minus 6 over 7 minus 5. And that's 3 over 2 for our slope. I could also list these as x2, y2, x1, y1. We'll get the same slope no matter what. 2 minus negative 8 over negative 3 minus 1. Well, that's the same as 2 plus 8 over negative 3 minus 1. And that is 10 over negative 4. We got to reduce because I hate fractions that we can reduce. So that's negative 5 over 2. Label them again, x1, y1, x2, y2. Slope is negative 3 minus negative 7 divided by negative 4 minus 0. Negative 3 minus negative 7 is the same as negative 3 plus 7 over negative 4. Well, that is 4 over negative 4, which is the same as negative 1. If I were you, I'd pause here and figure these out and then come back and check your answers. We can label these again, x1, y1, x2, y2. We've got the slope is 6 minus 6 over 7 minus 5. That's 0 over 2. 0 divided by anything is 0. Label my points, x1, y1, x2, y2. I've got slope is negative 8 minus 2 divided by negative 3 minus negative 3. Well, that's negative 10 over 0. Anything when 0 is in the denominator, the slope is undefined. I like a good rhyme. If 0 is under the line, it's undefined. Under the line, undefined. Little memory trick there. Last one, we can label our points. And we've got the slope is 0 minus negative 1 over 0 minus negative 4. That's 0 plus 1 over 0 plus 4. So the slope is 1/4. We have definitely done these before. Now we're going to use the same slope theory and find the missing coordinate value so that this line that passes through the 2 points has the given slope. So let's go ahead and label our points just like we did. But now we know that y2 minus y1 over x2 minus x1 equals 4 over 5. Let's simplify where we can. Can't simplify y minus 1. Negative 2, minus 3 is negative 5. And that's going to equal 4 over 5. Now we can cross multiply and solve these. Got y minus 1 times 5 equals negative 5 times 4. That's 5y minus 5 equals negative 20. And solve for y. Add 5 to each side. 5y is negative 15. Divide by 5. And our missing y is negative 3. Do the same thing to the next problem. We can label our points, x1, y1, x2, y2, and we have m. So y2 minus y1 divided by x2 minus x1 equals negative 2. Simplify where we can. Negative 4 minus negative 6 is negative 4 plus 6. So that turns into 2 over 5 minus x equals negative 2. We need to get x out from the denominator, so I'm going to multiply both sides by 5 minus x. It's 2 equals, those cancel, negative 2 times 5 minus x. Got to distribute, negative 10 plus 2x. Add 10, 12 equals 2x. Divide, and x equals 6 is our missing value. Let's just kind of fill in the formula and see what we get. Now we're going to talk about the slopes of parallel and perpendicular lines, because now we're in geometry. Those are the kinds of things that we care about. Parallel lines have the same slope. They never intersect. And they are equidistant from each other. Okay, railroad tracks. Think railroad tracks. In this first example, this is what they look like. First example, these are in slope-intercept form, y equals mx plus b form. So we know that the slope is the number directly in front of x. So our slope is 2. In the second example, we have 4x plus y equals 2 and 4x plus y equals 4. Well, these are in standard form. Ax plus by equals c. And if we want to find the slope in standard form, that's going to be negative a over b. So we have negative 4 over 1, which is negative 4. And then last but not least, we have standard form again, ax plus by equals c style. Our slope is negative a over b. So we've got negative 2 over negative 3, which is 2/3. Perpendicular lines have negative or opposite reciprocal slopes and create 90-degree angles. So they look like that. So if we're given a slope of 5, perpendicular slope is the reciprocal, 1 over 5, with the opposite sign in front, negative. If our slope is negative 2/3, we take the reciprocal, with it's negative 3/2, reciprocal of that, and the opposite sign is positive. If our slope's negative 10, we do the reciprocal, 1 over 10, and opposite sign, so it's positive. If the slope is 1/4, it's now going to be negative and 4 over 1. Okay, it's just got to remember the opposite sign, opposite inverse. Flip it over, opposite sign. Given the points A, B, C, and D, determine if A, B, and C, D are parallel to each other. So first, we have to get the slopes of these lines. The slope, holy cow, who knows even what that is? I'm so sorry. Woo, startling, wasn't it? Yikes. So the slope of AB is going to be, if we list them, x1, y1, x2, y2, 2 minus 5 over 3 minus 4. That is -3 over -1, or 3. The slope of CD is going to be, I need an of here. It looks like the measure of AB, and that's not what it is. 0 minus 6 over -3 minus -1. That is -6 over -2, or 3. So we can say, yes, they are parallel because the slopes are the same. Now we want to know if AD and CB are perpendicular to each other. We need the slope of AD, and that is 0 minus 5 over -3 minus 4. That's -5 over -7, which is positive 5/7. Slope of CB is going to be 6 minus 2 over -1 minus 3. That is 4 over -4, or -1. So our answer is no, they are not. Shorthand for perpendicular is an upside down T, because the slopes are not negative reciprocals. Hope this makes all sorts of sense to you. I hope it's ringing a bell from your Algebra 1 days. I hope you're doing great. I hope to see you soon.